How are you?
Good. How's the tennis going?
Good. Tennis is fine.
Yeah?
Yep. I was in Oregon last weekend.
Uh-huh. Your mom said you were traveling, yeah.
Yeah, so that was fun. It was a good experience.
Yeah?
So
do you travel by yourself, or do you go with a coach, or your dad? Or
this particular tournament I went by myself, and then I stayed with like another family.
Uh-huh.
So
cool.
yeah, it was good. I won a few matches and I lost a few matches, but
yeah,
overall it was a good tournament.
Cool. Cool. No,
Yep.
It's exciting. I've always played tennis, not very well, but what I do play pretty good is table tennis.
Oh, really?
A lifelong table tennis aficionado. In fact, I have a robot in my living room. If I turned my camera on, you'd see something that looked like a ping pong robot, similar to a tennis machine that fires balls at you.
That's awesome.
Yeah, it is. It actually makes for a really good workout machine for me. Because the thing you load about 200 balls up, and then you hit them back into a net, which gathers in a trough and feeds them back in. So
it just goes forever.
It does. You can literally go forever if you're accurate enough to be able to hit the giant net. But it's pretty cool. Yeah, I get a real good workout on that thing.
Well, good.
So what are we doing math-wise tonight?
All right. Well, I have a test on Chapter 5 coming up this Friday, so that is pretty much it. So Chapter 5 consists of... do
you have some problems that you can verbalize?
Yeah. Let me see.
That's usually the best way to understand math is through problems. So.
All right. So if there is 7 sections that I'm going to be tested on Friday, so do you recommend that we just start at 5-1 and then work through 5-7?
Yeah, let's go through each section until you know how to do it. And if you know how to do it right away, we'll skip to the next section.
All right. So, let's see here. 5-1 is all about quadratic equations.
Okay.
And these ones, I think, are very straightforward. However, could we do some completing the square problems?
Sure.
Do you want me to give you some, or do you have a few?
I can make some up.
All right.
Let's start with a basic one. There's one we can't factor.
Okay.
Since we can't factor it, we could plug it into the quadratic, but we can also solve it by completing the square. The quadratic formula comes from completing the square. That's how it was derived. So what's my first step for completing the square?
You got to move the 13 to the other side.
Yeah, and that's because that's odd, because that's not usually what you do with a quadratic.
Right.
You usually leave everything on one side and 0 on the other. So right away, this is an unusual step. But now we want to complete the square where we have the x squared and the x term. So what do I need to do to complete the square?
We need to do 1/2 of 6 and then square that, so then we get 9.
Okay, and it's always plus, because even if it's a negative number, by the time you square it, it's plus. Means I have to add 9 to this side also. And now by virtue of completing the square, how can I write the thing on the left?
We can write it on the left as x parentheses x minus 3.
Right. Whatever that half of that was is always what it's going to be.
Yep.
Okay. So now we have this. Now what?
From there, we go plus or minus. Oh no, now we have to do a square root both sides.
Because whenever you take the square root of both sides of an equation, the first thing out of your mouth needs to be plus or minus, so that you don't forget. Okay? Because most people forget it. They do. Most people would say the next step is x minus 3 equals the square root of 22. But we know that there's a plus or minus there.
Plus or minus there.
So now one more step gives us the solution. X equals 3 plus or minus the square root of 22.
And let's say if it was like, if it ended up being like the square root of 16, would we then reduce it to 4?
Yes.
Or,
in fact, anything that is reducible. This is not reducible because this is 11 times 2.
Right.
But let's say that that was 40. Square root of 40. You don't leave an answer that can be simplified. Okay? Square root of 40, what does that simplify to?
Square root of 10, square root of 4?
Which means what?
Then that can go to 2 root 10?
Right, and that's simplified. In other words, I could change the root 10 to root 5 times root 2, but that's not simplified. In other words, that's more complicated than root 10. It's 2 terms than 1. So if you cannot pull a whole number out of it, it's simplified. I could not pull a whole number out of the 22. I could not find a perfect square that's a factor of 22. So that's as simplified as it gets. Now, let's go back and make the problem a little more difficult.
All right.
By adding a 2 there. And let's make this 6 a 8. And so now we have this. Right?
Yep.
Now what? In other words, you can't complete the square until this coefficient is 1.
So we're going to have to pull out 2.
Okay.
So we'll get 2 parentheses x squared minus 4x, and then equals 13.
Okay. The key is to never change anything. In other words, if I start with that, I have to make sure that at every step along the way, I have not changed anything. I mean, I can add a certain amount to each side, but this equation basically has to be the same all the way through. Okay, so now let's complete the square inside.
So then we get plus 8.
Actually,
or I mean plus 4.
Plus 4, and then what do I have to balance it out over here with?
A plus 8?
Yes. Right. In other words, the moment I wrote 4 in there, I really added 8 to the left side of the equation.
Because we're going to end up multiplying the 2 in.
Yes. And in fact, had I factored out a negative 2, and still ended up writing a plus 4 in there, now what I've done is I've subtracted 8 from the left side of the equation.
So we're going to have to subtract 8 from the right side.
Exactly. So you always combine what you added in to complete the square times whatever you factored out. And that's what you have to balance it on the other side by. That's as hard as you're going to get on completing the squares, is where you have to factor something out, and most of the ones you're going to see will probably leave whole numbers. Not that it has to. I can still handle a 7 there. The way I would have to do it is factor the 2 out, leaving 3.5x. Now I just have to take half of 3.5 and square it, and whatever that number is, write it in there, and proceed that way. So odd numbers or fractions don't hurt anything. You use exactly the same strategy. but I don't think you'll see any like that. That's a level probably harder than what
that's a
you
little
run into.
Yeah.
All right. So is that what else in section 1 besides completing the square do you need to be able to do and factor? I assume that part of section 1 is factoring?
I think factoring was section 3.
Okay.
Let's
go. Let me have you go through all the sections. Yeah. You tell me what you want to go over.
All right. So, I'm fine on that. Section 2 is the quadratic formula. I mean,
okay.
Yeah, quadratic formula, and
you have that.
I understand
you have that memorized. You know how to do that.
Yep.
Okay.
So I know how to do that.
Okay.
So
let me give you one, just as a test.
All right. All right. Let's do it.
Solve that using the quadratic formula.
All right. So we're gonna go.
What's A, B, and C?
So A is 2.
Okay.
So A is 2, B is -6, and C is 10.
Okay, good. That'll work. Could we make this problem easier before we do that?
Could we take a 2? Could we take the 2 out?
Yeah, we could just divide both sides of the equation by 2.
Right.
That turns it into this. Still equal to 0, because when you divide 0 by 2, you still get 0. Now my A is 1, my B is -3, and my C is 5. And the advantage is now you're dealing with smaller numbers. And smaller numbers always lead to greater accuracy.
Yeah.
So if you can reduce numbers,
we still have the exact same problem.
You do.
Yeah.
It's the exact same problem. You're still going to get the exact same solution that you would have gotten using 2, -6, and 10. It's just, and you know, since there's squaring going on, anything that you can use to reduce the size of the numbers is good.
Right.
Because instead of squaring 6, I got to square 3. And, you know, doing the arithmetic is much easier if you got smaller numbers.
Yep.
All right.
All right. So then now we just take those and we plug them into our equation.
Yes.
So we're going to get x equals +3 plus or minus the square root of -3 squared minus 4 times 1 times 5 all over 2 times 1.
What kind of solutions are we getting here? Have you had imaginary numbers yet?
Imaginary numbers is, yeah, I have. We just learned it the other day.
Let's finish.
And I believe it's going to be on the test.
Okay, well, let's finish this then.
All right.
Because this produces an imaginary solution.
Okay.
Because I just made the numbers up off my top of my head, so.
Yeah. So then we're going to go x, and then we can just combine all the numbers. So
no, let's just, yeah, let's combine these numbers. What ends up inside the radical sign?
-20 times 9.
9. Be careful that you don't make the mistake of multiplying. In other words, this is always a fraction. So it's 9 minus 20.
Oh, yeah, that would have been a bad mistake. Yeah.
All over 2. Now let's turn that into a solution that we can present.
So we're going to get x equals 3 plus or minus 11i?
Not quite. Whenever you have this problem, always start out by factoring out a -1, leaving that.
Okay.
So it's root 11I.
Oh, yeah.
Okay.
Because the root -1 turns into
Right. In other words, if you always do this as your first step, you won't make that mistake. Okay. So my answer then is root 11I all over 2. And then that might be a sufficient answer. It is key and important to know that that means x is equal to 3 plus root 11I over 2, and the other solution is x equals to 3 minus root 11I all over 2. Now, would they ever make you put it in A plus BI format?
We have not learned that yet.
Okay, we won't go there then, because otherwise I'd have to split this thing up into the real part and the imaginary part.
Oh, I think
Maybe.
In class today, the teacher, we haven't learned about splitting it up like from there,
Okay.
but she did say, like we did a little thing where you have to like A is the real, so then like you solve the reals and then solve
Here's the standard. The standard format for an imaginary number is that A plus BI. Well, we don't have this in that format, but I can make it in that format by splitting it up into 2 fractions. So there's the 3/2 plus the root 11 over 2I. Now I've got it in A plus BI format. A is 3/2, B is root 11 over 2. In other words, that's A plus BI format.
Okay.
Okay, and that's all it is when you take your final answer and split it up into 2 pieces. You know, you can always, if you have A plus B over C, that's always equal to A over C plus B over C.
Right.
All right.
All right. So I think we're good for those. We're gonna come back to imaginary numbers in a few minutes here, though, I think.
Okay.
But let's just keep working down the line. So then 5-3 is factoring quadratic equations. And that's where like all the difference of squares and difference of cubes comes into play.
Okay.
And those have been confusing for me.
Okay, let's start with difference of squares. I think I can give you a good method of memorizing it.
Okay.
Memorize it like this, not the reverse. And I'll show you why. The first term is always linear and always has the same sign.
Okay.
If you're factoring difference of cubes, the second term is a quadratic and it has the opposite sign in the middle term.
Oh.
And if you have sum of cubes, the first term is linear and the same sign. Second term is quadratic, opposite sign. So the only thing you have to remember is the first term is linear and always has the same sign as this.
Oh yeah, it's the same.
Yeah.
Yeah, it's the same. Okay.
Okay. So if you use this technique, now you can factor most anything. So let's look at x squared minus 4. What would that be equal to?
That is equal to, isn't it x squared minus 4 plus 4, or am I making that up?
If I'm trying to figure out what a and b are, well, a is x, right? B must be 2. to end up with x squared minus 4, b has to be 2. So it's x minus 2 times x plus 2. And the way I get a and b are just a is the square root of that, b is the square root of that.
Oh, okay.
Okay?
Yeah.
Okay, let me do another one. X squared minus 64. Factors into what?
X squared minus 64 factors into...
Notice it's the difference of perfect squares. That's the first thing you need, is the difference of perfect squares.
Okay.
Okay.
So it's going to be x and then 64 squared.
No, the square root,
right?
yeah, the square root of 64.
Square root of 64, yeah.
So it's x minus 8 times x plus 8. Now we'll make them a little harder.
Okay, so 4x squared minus 1, we're going to have...
Again, it's the difference of perfect squares. That's a perfect square, and so is 1.
So we're going to have 2x, x minus 1.
Yep.
And then 2x plus 1.
Yeah, the second part's always just the conjugate of it.
Oh, okay.
So now this one a lot of people don't see because they don't think of 1 as being a perfect square number, but it is. So whenever you see that 1, think difference of perfect squares, at least if this thing is a perfect square.
Okay.
Okay, now let's, as long as we're on this subject, you have to know perfect difference of cubes and sum of cubes also.
Difference of cubes, sum of cubes, and perfect square trinomials.
Okay. Let's do a difference of cubes. Again, a is now the cube root of the x cubed term. Remember, we're doing this one right here.
Yep.
So what's the linear term?
The linear term, so it's going to be x. Oh, because, so doesn't...
What's b?
So when...
b
That's
is going to be the
going to
cube
be
root of 8.
which is going to be 2.
And then the rest of it?
Is it just the conjugate again?
No,
or...
no, it's a little more complicated this time. But really, when you're doing difference of cubes and sum of cubes, it's worth doing something before you proceed. And that's spelling out what a and b are. In other words, when I've got x cubed minus 8, I know a is x and b is 2. So now that I know what a and b are, plug it in to this over here for the quadratic expression part of it.
Oh.
So a squared is...
So then we're just going to have x squared plus x, or 2x.
Good.
Plus 2x plus 2 squared.
4. So that's how we would do difference of cubes. Now, let's do another one of those.
All right.
What is a and what is b?
A is 2x and b is 3.
Okay.
Okay, so then for the first part we're going to have 2x minus 3. And then for the second part, we're going to have 2x squared.
Which is what?
4x.
4x squared.
4x
In other words,
squared.
if I'm going to write it the way you say it, then I got to put parentheses around it. I got to do that. But
Okay.
I'm going to remove those parentheses the next step, so let's just write it as 4x squared. Okay?
So then we get 4x squared minus AB, so minus...
Plus. Remember, the sign of the quadratic is always opposite the sign of the linear in the middle term.
Quadratic is opposite. Oh, yeah, whoops, I wrote the wrong thing down.
In other words, this is opposite that, this is opposite that, and even at the top, that's opposite that.
Right.
So all the terms have opposite signs in the middle.
Got it.
So this is
going to be it's going to be plus 6x plus 9.
You got it.
Awesome.
Let's do one more sum of cubes. Now notice there's no factoring sum of squares. You can't factor x squared plus 1. It doesn't factor. But x cubed plus 1 does, because it's the sum of perfect cubes.
So, okay, so then we're going to get...
we'll make it a little harder. We'll do that. X cubed plus 8.
Okay. So then we're just going to just follow, so A is going to be x, and then B is going to be 2.
Okay.
So then from there we just plug it into what we have above. So then we have x minus 2.
Hold on. Remember, this linear term always has the same sign.
Same sign. Got it.
And that's why I have people memorize the difference of squares. A lot of people will tell me the difference of squares is a plus b times a minus b. And I usually try to correct them into memorizing it the reverse way. Because if you memorize all of them kind of together, then you see that the linear term, the first linear term, is the same sign as each of these.
Okay.
And the second term, linear or quadratic, has a different sign in the middle.
Right.
So it becomes real easy to memorize if you memorize this difference of squares as a minus b times a plus b.
Okay.
Okay. So the rest of this?
So the rest of that is going to be x squared, then the opposite, so minus 2x plus 4.
And that's the way you do difference, sum, and difference. Yeah, that's probably all we need to do on difference and sum of squares and cubes.
All right.
Now there's perfect trinomial.
Yeah.
What's a plus b squared equal?
A plus b squared equals a squared plus b squared? No?
No.
Yeah.
There's a middle term. Notice that if we FOILed that out, and that's what you would normally do,
right,
you end up with this. And if you do this one, it's very similar. And in fact, notice how similar it is to the quadratic term on sum of cubes and sum of difference of cubes. The only difference is we have a 2 here instead of just AB.
Oh yeah, it's basically the same though.
Pretty close. That's what it is here. It's just an AB, and down here it's 2AB in the middle. And the only difference between sum and difference is the sign of the middle term. So when they refer to a perfect trinomial, they're talking about that. Yeah. In other words, if I have x squared plus 2x plus 1, that is a perfect trinomial, which factors into x plus 1 times x plus 1. By perfect trinomial, they mean that the square root of it, you have two linear factors that are the same.
Okay.
Okay? And it could be x squared plus 4x plus 4. That is a perfect trinomial also.
Okay.
If I said factor this, you wouldn't really need to know it was called a perfect trinomial. In other words, I don't think they're going to give you a test that uses those words. They're going to give you a test that says factor this thing.
Yeah.
Okay? Now, you can never get too much practice factoring.
Right.
Notice both terms are the same. Whenever you have both factors are the same, you actually means you started with a perfect trinomial.
Oh. Okay.
Okay?
Oh, yeah. That makes sense.
Yeah, and I could construct all kinds of perfect trinomials.
Right.
By just making two linear terms the same, multiplying them together, whatever trinomial you get is the perfect trinomial. But you don't really need, that's not really a separate section about factoring. In other words, you factor that the same as you would a non-perfect trinomial.
Okay.
Let's do a little bit of factoring practice.
All right.
First of all, I should ask, do you want to keep going? It's 8:36. I can quit. I can quit now, or we can go to 9, or we can go to whatever time you want.
Whatever works for you. I mean, I have another meeting with you tomorrow night scheduled.
Okay.
It's just for like a final review. But maybe if we could just finish up factoring tonight.
Okay.
And then call it good.
Let's do that. Let me see if I can make up some factoring problems. Let me open my book, because the difficulty in making up factoring problems is you got to know, you got to factor it before you can make it up. You know what I'm saying? So let me pull some from my book. Let's start with this one.
Alright. So, with this one, we just go ahead so then we can put the x's in it.
I gave you a bad one. I didn't mean to give you one that needed the quadratic formula. I didn't realize I was looking in the book at one that was not factorable. Hold on, let me find one that's factorable. All right. There's two types of factoring. There's a simple factoring where there's no coefficient in front of the x.
Okay.
Let's talk about those first of all. How does that factor?
That factors out to...
you can do it step by step if you like, just verbally. So we have x and x, and then what next?
Then we're going to have a minus and a plus. And then it's going to be a the factors of 4, so it's going to be 4 and 1. And then the
there
positive...
are other factors of 4, 2 and 2. But you're right that it's 4 and 1 because it has to be factors of 4 that subtract because of that to the number 3. That's what makes it 4 and 1. Where's the 4 go? Where's the 1 go?
The 4 goes on the right next to the subtraction symbol, and the 1 goes on the left.
The way I think of that is the bigger factor, 4 is bigger than 1, goes with the sign of the middle term. Always. Let's do another one. Simple one. In other words, whenever there's no coefficient here, they're always going to be relatively simple. You certainly don't need any kind of a California method to solve these.
Okay. But then once you start putting a number in front of the x squared, then it gets a little trickier.
I've got one of those also.
All right.
A few of those.
So for this one, it's going to be x plus and x plus. And then we can just start going through all the factors of 88.
Well, they have to do what? What's the rule we're looking for?
They have to add to 19?
Correct.
So 88 and 1 probably isn't going to do that.
That's true. Yeah, it can be a little tricky coming up with the factors.
It's just kind of like educated guesses, I guess.
Well,
right?
it kind of is. It's just being. I don't know. I just when I look at 88, I think 11 times 8.
Yeah, that I did not think.
And that adds to 19. So.
Right.
But let's talk about factoring numbers, because actually you brought up a good way to do it. 88 and 1, and then I can cut the 88 in half and double the 1, and then I can cut the 44 in half and double the 2. I can cut the 22 in half and double the 4. So at a minimum, I've got those 4 sets of factors. And that's a relatively quick way to do it, because all you have to do is cut numbers in half and double the other ones. In other words, this would get me my 11 and 8 fairly quickly.
Yeah, that's pretty fast.
Yeah, and so whenever you're having to find factors of numbers, that's not a bad way to do it, is to start with the number in 1 and then just start cutting that in half and doubling the 1.
Yeah.
All right. Let's tackle one where there's a number in front. And these can be any letters. They don't have to be X, obviously. They can be R, they can be Y. Now, this has a disadvantage in that there are quite a few factors of 8, but the advantage is there's only 2 factors of 5.
Right.
Well, how should I
start? For this one, does it matter, like, if we would use 8 and 1 or
it
like
does.
4 and 2?
It does. That's why these are harder, is there's lots more combinations. However, I can safely say that you're almost always going to be right by choosing the 2 factors that are closest together.
Okay.
In other words, 4x and 2x. I'm always going to start there. That may not be the answer. The answer may actually be 8x and 1x. But it's a trial and error process. What are my signs going to be?
We are going to have a positive and a negative.
Yeah, but in this case it matters now. I can't just write plus here and minus here. I have to allow for a plus and a minus, but I also have to allow for a minus and a plus, because there's a different coefficient in front of the x.
Right.
So whenever that's the case, you have to allow for both if you know the signs are opposite. This is just the way I write it. Your teacher may not do it this way, but I found that this way works pretty cool. Yeah. So now factors of 5 have to be 5 and 1.
Yeah.
So might as well just start without even thinking. I'm going to try 5 there and 1 there.
All right.
Does that work?
So then now we would just FOIL it and find out, right?
You don't need to FOIL the whole thing, and I'll tell you why. I don't need to verify that term. I know that term is correct. I don't need to check that term. I know that thing is correct. So the only term I have to make sure is correct is the middle term. And you get the middle term by multiplying the insides together and the outsides together and adding the result. Well, this gives me 10x. This gives me minus 4x. Add them together, I get plus 6x. What does that tell me? I got the right number, wrong sign.
Wrong sign. So then we're just going to have to we can just take out the positive in front of the 5.
Yeah, that's what I can do is just move that 5 down to the negative sign and move the 1 down to the positive sign. And then erase the rest. And I know this answer will be correct because it just changes the sign on everything. So it turns everything to that.
And then that's works perfectly.
Yeah. Now, that's very helpful because if I go back to my starting spot, where I had a plus here and a minus there, and I knew my factors were 5 and 1, well, let's say I started doing it this way. I started with the 1 here and the minus 5 over there. Well, now when I check the middle term, I got a plus 2x, I got a minus 20x, that's minus 18x. That's not the right number.
No, that's not close.
Which means that I don't need to try a 1 down here and a 5 down here.
We know immediately we're going to have to switch them.
Exactly. In other words, I've got to have the 5 on this side. I've got to have the 1 over here. So the next thing I would try would be that. That gives me the right number, wrong sign. Now I move the 5 down there and the 1 over there. What I'm trying to say, I guess, is that when you test it and you don't get the right number, then you know the solution is not to just move it down to the other sign. It's to switch the numbers. And that's the trial and error part of factoring. You want to try one more? You tell me when you're ready to quit.
Let's do one more and call it.
Okay. And I'll put one with a number in it. And this time I'll do it where this is the, let's do r squared minus 13r. And I'm just going to use a different variable just so you're not shocked if you get a different variable on the test. Okay.
So we're going to get, so just off the bat, we know it's going to be 5 and 1, 5r and 1r.
Right.
5r. Signs are both negative.
Okay. Now, I can't use any rules such as factors of 6 to subtract or add to 13. All of those rules go out the window. It's just a trial and error process at this point. What are my factors of 6?
6 and 1 and 2 and 3.
What shall we try? Obviously 6 and 1 doesn't work because the 6 multiplies by the 5 and I'm way higher than I want. Okay. And
so
by the
we'll just...
general rule, use the two factors that are closest together.
Mm-hmm.
Let's try 3 there and 2 there. Bingo.
Perfect.
If I would have tried 2 here and 3 there, then that produces minus 2, minus 15. That would have been minus 17R in the middle. So that doesn't work.
That'd be too high.
And just switch them. But like I said, almost always you're going to find your answer in the two factors that are closest together, whether you're talking about the constant or the initial coefficient. Right. So that's an excellent place to start, is with the two that are closest together.
Yeah. Awesome. Yeah, that's neat that that works. Just the two closest together.
Yeah. All right, Casey. I will talk to you tomorrow night. We'll call it a 45-minute session today, and then we can do whatever you need tomorrow night. I've got you
awesome. Thank you very much.
Hour, unless, you know, right now the half hour afterwards is open. I can't guarantee that somebody won't come in and snatch that spot. So you might only get a half hour tomorrow night. But if you need more, you probably are going to have availability there.
Awesome.
All right, Casey. Talk to you
well,
tomorrow.
Thank you very much.
You're welcome.
Talk to you tomorrow.
Bye-bye.